Good afternoon, dear students. On previous lessons, we were solving tasks with equations of planes in the space, straight line in the space, and today we are putting all together. So our topic is mutual locations of points, planes, and straight lines in the space. So let me share my screen. I will remind you some theoretical information. So how to find intersection point of the straight line. By the way, we were finding it on the previous lesson. So we need to solve equations of system of equation of the line and the plane with transforming to parametric formula this equation. So angle between the straight line and plane. So how to find? So we can find the sine of the angle by this formula. So we divide magnitude of scalar product of normal and a normal vector and a direction vector by dividing by product of their magnitudes. Parallelism condition for the straight line and the plane, be careful. So as you remember that normal vector is the vector that is perpendicular to the plane. So that's why we need to check if normal vector and direction vector are perpendicular. So just their scalar product is 0. And perpendicularity condition is that the coordinates of normal and direction vector are proportional. This is the formula of distance between the point and the straight line. So here is point A that belongs vector AM. Oh, that belongs straight line L, and so how to get the distance? We evaluate magnitude of cross product of vector AM0. So yeah, so point M doesn't belong the straight line, of course. So vector cross product of vector magnitude of cross product of vector AM by direction vector of the straight line and divided by the magnitude of direction vector. So this is the condition for lines line in the same plane. So cross product of vectors of direction, or mixed product of direction vectors and vector based on points that aligned on this straight line is 0. So just coplanarity condition. And for line skewness, that this vectors are not coplanar. And this is the formula of distance between two skew straight lines. So we divide mixed product, so magnitude of mixed product by the magnitude of cross product of direction lines. Any questions about equations, about theory? Okay, if no questions, let's start solving. So first of all, we need to find the projection of point M on the straight line Q. Okay, so first of all, how to find it? We need to find the equation of a straight line M that is perpendicular. So we need to write down the equation of a straight line that is perpendicular to the plane Q. and for which M belongs. So, okay, let me start drawing. So we need to find equation of the following straight line for which M belongs this straight line, and then find intersection point. And let's start solving. So how to write down the equation of the straight line? Do we have everything for that, or we need to find more data?
We have everything.
Okay, so what we have, by the way?
We have plane
Yes.
and point M.
Okay, we have point M line on this straight line, and what else? So we need to find such uh, straight line that is perpendicular to the plane, not P, but Q. Yeah. Well, I will remind you so that direction vector over the line L is is matching with the normal vector over the plane Q, and its coordinates are the following. So from this equation, 2 minus 2, 10. Well, oh, yeah, so okay, let's take this one, but by the way, we can even divide it by 5, so let's do it. So I will write in the following way. So normal vector is this. So I will move 2 out of brackets. So the direction vector is the next. Okay, and the canonical equation is the following. So x plus 2 by 1 equals y by minus 1 equals z minus 3 by 5. So this is the canonical equation. And now we need to transfer to the parametric equation. So it equals t. So we need to find now we need to find the intersection point of this straight line and plane. Let me extend it a little bit. And now we will do the same that we were doing before. So this equation will remain without changes for now. So x, so everything equals t. So x plus 2 equals t, and so x equals t minus 2. Y equals minus t. And so z minus 3 equals 5t. So z equals 5t plus 3. And now let's write down the equation of the plane with the substituting x, y, and z with these parametric expressions. So 2t minus 2 minus plus 2t plus 10 5t plus 3, and it equals 0. Just let me verify here if everything is correct. Yeah, let's expand the brackets first of all. So 2 plus 2.
You forgot about +1.
Yeah. Thank you for your attention. It's important. Plus 1. Okay, so 2t minus 4 plus 2t plus 50 t plus 30 plus 1, and it equals 0. Okay. So, so 2, 50, 54t then so 54t minus 26 plus 27 equals 0. And it seems that something is yeah, yeah, for this task it was incorrect, such such reducing. But no, it seems okay. I need to recheck it. But what we have for now, so that t equals minus 1 second. So x equals minus 1 second. So minus 2.5. Oh, by the way, it's correct. Yeah. So basically, yeah, everything is correct, but here we need to multiply by 2. So yeah, reducing was correct. So never mind. So y equals 1 second. And z equals, so 3 minus 2.5, it equals 1 second. Yeah, so basically that's it. Yeah, and here is k, but okay, let it be n, as we called here. So it has the coordinates minus 2.5, 0.5, 0.5. So this is the projection of point M on the plane Q. And the next task is to find this symmetric, so point M prime that is symmetric to point N. So you saw the spoiler, but I guess you knew before how to find it. So how to find coordinates of xm, m prime. So which formulas do we have to use? Okay, maybe for better understanding, so for so to make it simpler, I will draw the plane. So point M, point N, and M prime. So it's symmetric to the point M. So how to solve? Daniel?
We no formula of the center of straight line using vectors, so we can from this find m prime.
Well, basically, so middle point of the segment.
Yes, we used this formula in previous task.
Yeah. So just reminding you. And so,
Previous-
sorry, you have a question?
No, I mistake. I mean, we used this formula in previous lesson.
Yeah, we used it. So 2xn minus xm. So, yeah, and let me copy and paste coordinates of m. So minus, so 2 and n, of course, as well we need. So minus 5 plus 2, so minus 3. Then ym prime. So 1 1 minus 3 minus 2. So coordinates of m prime minus 3 1 minus 2. Any questions about this task? No questions. Okay. And here. So let me continue. So the next task. Okay. Now let me do it more convenient. So the first part, we need to find equation of the plane. So we have the equation of the plane P1 and a straight line L1 and point M. And first of all, we need to find the equation of the plane P2 passing through the point M parallel to plane P1. How to solve? What do you remember? So what we have? Do we have everything that we need here?
Yes, but we need to remember formula.
Okay, I will remind you. So we have a normal vector. So normal vector for P1 and P2 is the same. So it has coordinates 5, 3, 5, 1, 5, 0, 3. So yeah, because planes are parallel, so normal vectors are the same. And we have the point. So for P2, the equation is the following. So we multiply coordinates of normal vector by x minus with subtracting coordinates of this point. So x minus 2, 0 for y, just skipping it, plus 3z, and it equals 0. If we expand, so 5x plus 3z minus 10 equals 0. So that's it. Then section B. So equation of the plane P3 passing through the point M perpendicular to the straight line L1. So the plane P is perpendicular to the straight line L1. So what will be the normal vector over the plane P3? Maxim?
It will be 1, 2, and 3.
Yeah, so it is the direction vector over L1. Yeah, and so this right in this, so the same form of the equation. So P3 x minus 2 plus 2y plus 3 plus 3z equals 0. So now let's expand. So x plus 2y, so 6 minus, plus 3z and plus 3z. And now let's calculate three members. So 6 minus 2 plus 4. So equals 0. So that's what we need. Then we need to find the equation of the straight line L2 passing through the point M perpendicular to the plane P. So, how to solve? Daniel, yeah?
We can find direction vector from plane P1, and we can substitute a point from M into this equation.
Yeah, so direction vector over L2 equals normal vector over P1 because it's perpendicular. So it equals 5,003. Okay, and let me copy and paste this point because every time we losing it. So equation of L2 is the following. The new question.
I want guess with of this equation of this line.
Sorry?
X minus 2 divided by 5.
Yeah, x minus 2 divided by 5. So if you started, continue.
Y plus 3 divided by 0. And z minus z divided by 3.
Yeah, so that's correct. Okay. So now part D. So equation of the straight line L3 passing through the point M parallel to the straight line L1. So we know the point and we need to find direction vector. So what is the direction vector? So maybe anybody else wants to answer. So coordinates of direction vector for L3. So it's parallel to the straight line L1. So the direction vector is well, it's the same as for L1 because straight lines are parallel. So the equation is the following. X minus 2 by 1 equals y plus 3 by 2 equals z by 3. So this is the equation of L3. Then we need to find an intersection point N of the straight line L1 and the plane P2. Well, so let's do it. I will just copy and paste for now this equation. Okay, and I will rewrite it already. So, okay, well, in details, everything, without skipping any details. So x by 1. It will be faster if I will write with my hands. So x equals t, y equals 2t plus 1, z equals 3t minus 1. So 5t plus 3t minus 1 minus 7 equals 0. So 5t.
You forgot about 3 multiplied by 3t minus 1.
Thank you for your attention. Yeah, I lost it. So 5t plus 9t minus 3 minus 7 equals 0. Well, just to save our time here, so we see that here is everything correct, so the answer is the next. So intersection point has the following coordinates. So 5 by 7 by and 17 by 7. So a lot of fractions just to save our time, because really it's kind of a long process. Okay, so this is the intersection point. Then distance between point M and plane P1. So who remembers formula of the distance between the plane and the point? Okay, I will remind you, yeah, because there are a lot of distance formulas. So it is the following. So we need to multiply coordinates of a normal vector and point M. So 5 by 2. I won't skip an y for now. For 0 by minus 2. Plus 3 by 0. Minus 7. And divided by the magnitude of normal vector. So 25 plus 9. Okay. And what we have? So 10 minus 7, so 3 by square root of 34. Let me verify. Yeah. Okay. And then we need to find the distance between point M and straight line L1. So the formula of the distance between the straight line and the point is the next. So we divide magnitude of vector. Okay, what we call M1 M by S, so cross product S1, and divided by magnitude of S1. So coordinates of, okay, point M1 has the following coordinates. So we can find, so it is the point that is a line on the plane L1, straight line L1. So 0, 1, minus 1, and it belongs L1. So coordinates of M1 M are the following. So 2 minus 4, 1. And now let's calculate this cross product. One direction vector, 1, 2, 3. Oh, let me check if so 2 minus 4, 1, 1, 2, 3. So coordinates are the next. So minus 14, minus 5, 9. So just not to waste our time with extracting such square roots and so on. So the magnitude of the vector of this vector, you know the formula. So we need just to calculate coordinates. We need to calculate squares. So we need to find square root of sums of square of coordinates. So basically all magnitudes are here. So the final answer is the next. Yes, Stanislav, some questions, right? Okay.
Looks like there is a mistake. 9 powered by 2 isn't 64.
Stop. 9, yeah. So let's recalculate. Thank you for your attention. Okay, so recalculating.
Can I ask a question?
Ask, yeah, feel free.
Why do we have plus 8k, but in the coordinate form we wrote 9 instead of 8?
Because it's my bad. So, so mistake is here.
It is a related mistake, yeah?
Yeah, so, by the way, let's double check what is happening here. So, minus 12i, correct, plus j, plus 4k. Yeah, so this part is correct. So minus 4k plus 6j, yes, plus 2i. So yeah, and when expanding the brackets, what do we have? So minus 12 minus 2 minus 14. Okay. 1 minus 6, so minus 5. Correct. 4 plus 4, 8. So mistake is here. Okay, on the break I will correct it. So here everything is okay. So correct. No mistakes for here. And here as well. And we have such not informative result, but anyway, we won't waste our time with trying to find square root and so on. Maybe any questions about this task? Okay, if no questions, we will move next, but first of all, I will correct the mistake. Mhm. Could be. Mhm. Yeah, so now everything is correct. Okay, so now let's do the next task. So we need to do some manipulations with the pyramid. Okay, so we have the pyramid. Let's draw it. First of all, for better understanding. So the next vertices, A1, A2, A3, and A4. So what do we have to do? So first of all, we need to write down an equation of the straight line L passing through points A1 and A2. And find the length of this edge. So how to solve? So what will be the direction vector of L? Okay, I will answer for you. So the direction vector can be then taken the next. So A1, A2. So it will have coordinates 3, 6, 3. Oh, yeah. So we can also reduce it by 3. So it will be easier for us. So 3 by 1 to 1. So the direction vector will be the next 1 to 1. Just reduce everything and simplify as much as we can. Okay. And the equation, so which point do you want to choose? A1, A2 to write the equation?
A1.
Okay, let's go with A1. So it was your choice. So x minus 2 by 1 equals y plus 1 by 2 equals z minus 1 by 1. Okay, and how to find the length of the edge? Now, Daniel?
We need square all, put in the power 2 all coordinates, add them, and make square root from them.
Well, basically, we need to find magnitude of this vector. So, generally speaking, yeah, and yeah, it was correct answer. So, the procedure of calculating. So, 9 by. Okay, so now we need these coordinates. So 9 plus 36 plus 9. So it's square root of 54. So I can move 3 out of this square root. So 3 square roots of 6. Yeah, and by the way, so square root of 6 is the magnitude of this vector. Okay, now let's so we need to find equation of the plane passing through points A1, A2, and A3. So how to write it down? Do we have everything for that? Okay, yeah, we have everything. Now we need to use equation of the plane passing through 3 points. And we have coordinates of them. So the form is the following. So x minus a minus 2, and here y plus 1, z minus 1. So 5 minus 2, 3 minus 2. Then y 5 plus 1, 2 plus 1, 4 minus 1, minus 1 minus 1. So it equals 0. I just can do it like this. By the way, let me check if everything is correct here. So 5 minus 2, 3 minus 2, 5 plus 1, 2 plus 1, 4 minus 1, minus 1, minus 1. So the final equation is the next after calculating the determinant. So I will skip such steps. By the way, you have the full explanation here. So detailed solution to save our time. And what else can we? What else do we have to do? We need to find the area of the face A1, A2, A3. So do remember how can we do it if we know coordinates? Daniel?
Probably vector product.
Yeah, vector product, cross product of A1, A2, and A1, A3. So A1, A2 has the next magnitude. No, magnitude coordinates. So, by the way, not the vector product, but half of the magnitude of the vector product. Be careful with that. when doing your home tasks, your homework. And A1, A2. A3. So coordinates of A1, A3. 1, 3, minus 2. So the cross product yeah, by the way, I could move 3 out of brackets, but let's leave in such form. And in order to not calculate determinant, so what we have, minus 21, 9, 15. So the magnitude is the next of this, so magnitude of cross product. So as well, we won't play with square roots. It's not such a useful procedure for now. Yeah, and so the area of A1, A2, A3 face, so it's area of the triangle, and it is the half of the magnitude of cross product. So very attentive when doing your homework, tests, and so on. Okay. The next task is next point is to find volume of the pyramid. So volume of the pyramid. How to find it? What do you remember about this from the vector algebra as well? Maybe anybody else wants to participate in the discussion to help your colleague. Okay, then you go on.
1/6 multiplied by mixed product.
Correct. 1/6 by the magnitude of mixed product.
Yes, yes.
Yeah. So, but yeah, if you receive negative volume, so anyway, it will make you think if everything is correct. So because volume is always non-negative. So it is the, oh no, let we first of all calculate just this mixed product separately. So we will write down the determinant. We won't pay attention to its calculation. So 363. And then 1, 3 minus 2. And A1, A4, so it has coordinates 2, 2, and 2. Yeah. And the result is the next. So minus 18. So the volume is the next. So 116 by the module of minus 18 and it equals 3. So this is the volume. Okay. Now then what we need to do, we need to find angle alpha between edges A1, A2 and A1, A4. So that just scalar product by magnitudes, by product of magnitudes. So cosine of alpha, so we find it first of all. Okay, A1, A2, so 3 by 2. But let me write in details, of course. So 3 by 2 plus 6 by 2 plus 3 by 2. So divided by, okay, let me expand it. So 54, by the way, and square root of 54 and square root of so 4 plus 4 square root of 12. So we won't play with the calculating square roots as well. So what we have 4 by 4 by 3 square roots of 2. And the final answer is the next. So this is not the value from the table, so just leaving this answer. And then we need to find angle beta between edge A1, A4 and face A1, A2, A3. So basically how to find it. The next formula, so how to find sine of beta. So we know the face coordinate of normal vector, and here coordinates of A1, A2, A1, A4 we have as well. So let me remember the coordinates of normal vector. So normal vector, so -7, 3, 1. So, by the way, I can move 2 out of brackets, out of magnitude as well. So just -7 plus 3 plus 1. 49 plus 9 plus 1 and by square root of 12. And of course, so what do we... Okay, I hope you didn't see the mistake in the text. Okay, so the sign is the next. So here is everything is correct. So square root of 3 by 59. And of course not b by beta. That's it. Maybe any questions about this task? If no questions, we will have a break for 5 minutes. Okay. So for now, break for 5 minutes. Okay, let's continue. So the next task, so we have two skew straight lines, so they are not aligned in the same on the same plane, and they don't. So it means that they are not parallel. They don't intersect, and we need to find the equation of their common perpendicular. So you know that it is, so the common perpendicular helps us to find distance between these skew straight lines. To better understand how to solve, we need uh, to draw. So let's draw such skew straight lines. Okay, let imagine that their common perpendicular must be that their common perpendicular must be here. So this is their common perpendicular, and they don't cross here, but of course we cannot draw in like so we cannot draw 3D graphics of it. So let it be L1 and this L2. And this is their common perpendicular. So first of all, we need to find the equation of the plane P, P1 that, okay, let we call it, oh no, here is Q. Okay, so we need to find the equation of the plane Q for which, so that is passing through the through the straight line L1 and parallel to L2. So this is Q, and let's write down that L1 belongs Q, and L2 is parallel to Q. So we need to find this plane. And then we need to find two perpendicular planes. So we need to find two planes that passing through these straight lines and perpendicular to each other. Let me try to draw it. So we will spend time more to drawing than to calculations, because it will be understandable if we calculate. Okay, and now I need to erase a little bit just for better understanding of what is happening. Okay, I will leave it like that. So what next? Yeah, this will be hidden. So I guess I believe that it is understandable. So this is P1 and this is P2. Planes P1 and and P2 are perpendicular. L1 belongs P2, P1, and L2 belongs P2. So, by the way, how to find the plane Q? Do we have everything for it? Or we need to find also its normal vector? Yeah?
We have everything.
Well, we need to find normal vector for the plane P, and how to find it for plane Q. We won't calculate it, but just write down the formula. Okay, go on.
I thought that we can write normal vector from members that divide coordinates of line, but now I
So,
okay. This line parallel, so their normal vector from them all is this perpendicular.
so what is lines L1 and L2? They are not parallel, they are skew. So we have direction vectors. So normal vector of the plane Q can be received as cross product of vectors S1 and S2 because it's perpendicular to these two vectors, both of them. So this is the normal vector of the plane Q. We won't calculate it now because it consumes a lot of time, and here we need to understand how to solve and rather than spend time for calculations. So we are finding first of all plane Q, and why do we need it? Basically, by finding plane Q, we will be able to find. So then we will be able to find normal vectors for P1 and P2. So how to find their normal vectors? Any ideas? Okay, Maxim, yeah?
I think they will be the same as for the lines L1 and L2.
So identically, but what you mean that it will be match their direction vectors, but it's not correct. So the normal vector is perpendicular to the plane, but the direction vector of the straight line is parallel or belongs the straight line. So we need to find the vector that is perpendicular, so vectors perpendicular to P1 and P2. Okay, so we already know normal vector of Q. So we found it from this, so by this formula. And vector n1 is perpendicular both to nq, so both to nq and s1. So it means that it can be found from this formula. And identically to n2. So normal vector for p2. So basically that what we need. So, and then with knowing normal vectors of these planes, we also have points that belongs to these planes. So M1 with coordinates 0, 1, -2. So because L1 belongs to P2, so M1 belongs to P2 as well, or P1, sorry. And M2 -1, -1, 2. That belongs to P2. So with the normal vectors and points, we can write down equations of P1 and P2 planes. And why do we need to write down the equation of P1 and P2? Basically, why do we need it? Because we will receive a general form of the equation of the straight line. So okay, I won't write it down here, but let's just have a look in this file. So found plane Q. Yeah, and here I will have to correct the letter. So found equation of P1, found equation of P2, and just wrote down the perpendicular of H, so it is the intersection of planes P1 and P2. And this is the general equation, as you remember. So equation of the first plane, equation of the second plane. So the task was just to find equation of the common perpendicular. Which form? No details about it. So general will be enough. But of course, it can be reduced to canonical if required. How to do it, you already know. Any questions about this task? Okay, I guess that no questions. So now let's move next. Let's solve the next task. So we have the plane and the straight line that doesn't so that is not aligned in the plane P. Yeah, so a little bit incorrect symbol, but never mind. So first of all, we need to find a sine of the angle between P and L and their intersection point coordinates. So let's start. The sine. Okay, let we call it phi. So this angle. So the sine of phi will be calculated by the next formula. So we need to calculate scalar to divide magnitude of scalar product of the normal and direction vectors, and then divide by product of their magnitudes. So nothing hard for now. So 1 by 0 plus 1 by 2 and minus 1 by 1. And here, so square root of 5 by square root of 3. So 2 minus 1, so 1 by square root of 15. So found sign between this sign of the angle. Yeah, correct. And now we need to find intersection point N. So let's start solving. So just revising a lot of times today the intersection point of the plane and the straight line. Okay, so what we have? So x equals 0t plus 1. So x equals 1. So 0 coordinate of the direction vector, it just means that the coordinate of the plane is always constant. So it means that x always equals 1. So each point line on this straight line always has x coordinate 1. And that's it. So no division by 0. So y equals 2t. Z equals t minus 1. So, yeah, and then what we have 1 plus 2t minus t plus 1 equals 0. So t equals minus 2. Let we check it. Oh, minus 3. Why minus 3? And one moment. So 2t, t minus 1. Forgot 1, of course, plus 1. So yeah, it equals minus 3. So my bad. And n has coordinates. So 1, minus 6, and minus 4. Then we need to write down equation of the plane Q passing through the straight line L perpendicular to the plane P. Okay, let me copy and paste it. So the plane Q perpendicular to the plane P. So we need to find the normal vector of the plane Q. So we know that L belongs Q, and Q is perpendicular to P. So what we know? So as Q is perpendicular to P, we know that the scalar product of normal vectors of P and Q are so the scalar product is 0. So normal vector of P equals 1, 1 minus 1. So it means that AQ plus BQ minus c with index q equals 0. So we will have to find such coefficients, but that not enough information. What else do we need to find? So yeah, so they are perpendicular. Yeah, by the way, sorry, NP and Q. Yeah. So we also must remember that it is perpendicular to the direction vector over plane of the line L. Yeah, because that's not enough for us. So, and it means that, so yeah, SL, which coordinates has so 0, 0 to 1. So to BQ plus CQ equals 0. And we have the equation, a system of linear algebra equation for these coefficients. By the way, it's also homogeneous. So let we assign C, so let we make it free variable. So C equals to B. Yeah, by the way, no. What we express B by C, so through C. So BQ equals minus 1 second CQ and AQ equals C Q minus BQ. So it equals 3 by 2 CQ. So now let's decide which values do. So which value of C do you want to use for our convenience, first of all? So what can you suggest?
One second.
Are you
No,
sure?
no, two. Just
Yeah,
two.
2, just to eliminate these fractions. So A equals minus 1 and B equals 3. And so now, so we found a normal vector over Q minus 1, 3, 2. Yeah, so be careful with the order. Okay, I will correct it now, just not not to let you get confused. So coordinates of Q we have, and so as L is aligned on the plane Q, we know the coordinates of the point M that is aligned in such plane. So minus x plus 1 plus 3y plus 2. Stop. X minus 1, yeah. Be careful with coordinates. So z plus 1, yeah, because M has coordinates 1, 0, minus 1. and q as well. Yeah, and it equals 0. So this is the equation of the plane Q. And what else do we have to find? Write down the equation of projection L or the straight line L on the plane P. Well, basically, what can we? So just to save our time, we will look at it here. So this is the formula of projection. So how to find the projection of the line on the plane. So we need to find the direction vector of this projection. So S for L prime, and this is the next formula. So we subtract from direction vector of initial straight line, we subtract normal vector of the plane multiplied by scalar product of normal vector and direction vector divided by the square of the square magnitude of the normal vector. So there are coordinates of this direction vector. And we need also the point that is aligned on the plane P. We already found point N, that is the intersection, and with the coordinates of direction vector and the point that is aligned on the projection on the straight line, we have the following equation. Any questions about this task, about previous task, previous lessons, and so on?
No.
No.
Okay, if no questions, so we are finishing. Have a nice day. Stay safe. Thank you for your attention.
Thank you. Goodbye.
Thank you. Bye.
Thank you, goodbye.
Bye.
Nice day and weekend.
Thanks.